Hello. Today we'll discuss the classification of signals. Five methods of classifying signals are there, that is based on different features. The first we'll discuss the continuous and discrete time signal. The continuous time signals are generally, in this contains a signal except t is said to be a continuous signal if it is defined for all time t. It is defined for all time t. So this is the function x of t which is defined for all time t. So this is a continuous time signal whose amplitude or value this is varies continuously with the time, and the continuous time signals arises naturally when a physical waveform such as it may be the sound waves, sound pressures, and the microphone is the example. In microphone, the sound waves, sound pressure variations are there, and this will cause the variation in voltage or current. And the photocells which does the same for variation in line intensity. So this is the continuous time signal. Discrete time signals, it is defined only at a discrete instant of time. Only for only uh, at only at discrete in discrete instance of time. So it is not defined for the continuous instant of time. So discrete time signal, it is defined only at a discrete instant of time, and therefore the independent variable has discrete values. Which is the independent variable here? The time, and this independent variable has a discrete value which are usually uniformly spaced. So this discrete time signal is generally derived from the continuous time signal. Discrete time signal is generally uh, derived from the continuous time signal by sampling it at a uniform rate. By sampling it at uniform rate. And therefore, let Ts is the sampling period and n denote the an integer hello बोलो इसी सेमिनार हम लोग So n denotes an integer with positive or negative value. Okay, therefore then sampling a continuous time signal x of t, we have to sample the continuous time signal at time t is equal to nt, and which will give you a sample value, which will give you the sample value of x of n ps. So this is a discrete function. Okay, whenever the n is there, that is a discrete function, and whenever x of t is there, this is a continuous function. Okay, therefore for convenience of presentation, we can write here x of n is equal to x of n into t of s, and where this n is equal to 0 plus minus 1 plus minus 2. Therefore discrete time signal is represented by the sequence of number. The sequence of number may be like this: x of minus 2, x of minus 1, x of 0, x of 1, x of 2, x of 3, like this. So this is a sequence of numbers. Okay, so this is all about the continuous and discrete time signal. Now we will see the even and odd signal. A continuous time signal x of t is said to be an even signal if x of minus t is equal to x of t for all t. So the continuous time signal x of t is said to be an even signal if x of minus t is equal to x of t for all t. This is, if this condition is there, then this is an even signal, and the signal x of t if x of minus t is equal to minus x of t for all t. Okay, so this even function is symmetric about vertical axis, and odd function is anti-symmetric about the time origin. If the function which is symmetric about the vertical axis, we can say it is even function, and if the function is anti-symmetric about the time origin, we can conclude it is a odd signal or odd function. We are talking about, actually this is a, instead of function, it is a, we are talking about the signal. So even signal and odd signal. No doubt it is a function, but as we are talking about the signal, so even signal is symmetrical about the vertical axis, An odd signal is anti-symmetric about the time origin. Okay, so let us now suppose we are given the arbitrary signal x of t, and we may develop the even and odd decomposition of x of t. We have to decompose this arbitrary signal x of t. Okay, so if you can decompose, we can write this even component of this function and the odd component of this function. Okay, so this is the even x of is to be even component, and this is the odd component. So the arbitrary function x of t is decomposed into the two component. One is the even component, another is the odd component. Therefore, we can write here according to the definition. According to the definition, we can write the even component like this: x of e of minus t is equal to xc of t, and x naught of minus t is equal to minus x naught of t. This is according to the definition. Okay. Now, what we have to do? We have to put here, substitute t is equal to minus t in x of t. If you put here, we'll get, what is the equation? X of t is equal to, we have to put here t is equal to minus t, and x of xc of t. So we have to put here t is equal to minus t plus x naught of t. So we have to again put here minus. Okay. So just what is x e of t? From this we can write here, this is the value of, okay, we can write here, instead of xc of t we can write here xc of t, and instead of this we can write here x0 of t. Okay, so now we have the two equations. Equation, we can call this as equation b, and this is equation a. So we have to just add this equation one at one time, we have to add, and on at second time we have to subtract. So by adding these two equations, what we get, we will get xc of t is equal to half into x of t plus x of minus t. This is equation one condition, and by subtracting equation a and b, we will get x naught of t is equal to half into x of t minus x of minus t. So this is the even and odd component of the function. This is the even component, and this is the odd component. Okay, so in this way we can find the even and odd component. So let us take one example. Example is that signal is given x of t is equal to sine of minus pi of t by t. Okay, this signal is defined for t which is less than t which is less than or equal to t, and it is greater than minus t. So this signal is there, sine of minus pi t into t. So we have to check whether the signal is if the given signal is even or odd signal. How you can check this? Just solution is where to put t is equal to minus t in x of t. Okay, so x of minus t is equal to sine of the function given is like this. Okay, the function given is like the sine of pi t by t. Okay, so what we have to do? We have to put t is equal to minus t, and if you put here minus sign, here t is equal to minus t, the function will become pi t by t. Okay, and sine of minus of something is minus sine of pi t by t. Okay, so therefore, what is this? This is equal to x of minus t is equal to minus of x of t for all t, and this satisfies the odd component. Okay, we have seen the definition of odd. This is the definition of odd. X of minus t is equal to minus of x of t. So this condition prevails here. X of minus t is equal to minus x of t. Hence, the given function x of t is an odd signal. So in this way, we can calculate the given signal is the odd signal or even signal. Let us take one more example. X of t is equal to this function is given to x of t is equal to e raised to power minus 2t into cos t. So solution is that put x is equal put t is equal to minus t in the above equation. So x of minus t is equal to e raised to power 2t into cos of minus t. So after putting t is equal to minus t, and therefore this value becomes here e raised to power 2t, and cos of minus t is cos t, and therefore this is x of minus t. Now we have to apply actually we are this function is given x of t is this, and we have to find even and odd component of x of t. What is required to find here? We have to find the even and odd component of the given function. Okay, so we have put here for t is equal to minus t, we have got this. Now what is the even component of the function? We already find this. Even component of this function is equal to half into x of t plus x of minus t. Okay, so half into x of t is, it is given, x of t is e raised to power minus 2t into cos t, and x of minus t we have got here e raised to power 2t into cos of t. So here we have to take the cos t outside. So cos t into what is remain there, e raised to power minus 2t plus e raised to power 2t. So cos t, so instead of this e raised to power minus 2t plus e raised to power 2t by t, we can write here cos h of 2t into cos t. So this is the even component of the function. Next is the odd component of the function. We have to find the value is half is equal to x of t minus x of minus t. Okay, so I have to just put the values. X of t we have got here half into x of t is e raised to power minus 2t into cos t minus e raised to power 2t into cos t. So here cos t we are taking outside. What is remaining, e raised to power minus 2t minus e raised to power 2t by 2, and instead of this we can write here minus sin h 2t into cos t. So this is the odd component of the function. This is the even component of the function. So in this way we can check whether the given function is even and odd, or we can also find the odd and even signal. Thank you very much for watching this.